Hello everyone, welcome back to my the this tutorial session for binary heap and priority queue. So this time we are going to build a heap. So in our previous discussion, we talked about the basic operations of binary heaps, which are insertion, deletion, and uh, finding for parent, left child, and right child of no, a certain node. So we follow the same. We implemented max heap in that, and then uh, there are binary heap follows the order of should be complete binary tree, and at the same time the heap order property, which is if you're going to use max heap, all the nodes, all the nodes in the parent node root node must be greater than to its children. Okay, so if you're going to use min heap, the property should be all nodes in the parent node should be less than to its children. Okay, so now before I mean in our previous discussion we we tried inserting a node to a certain to a binary tree to an existing binary heap rather, and then we just have to insert it at the in a level order manner to make it complete binary tree, and then after that you perform percolation app. Okay, so that the percolation app following the heap order property, and of course the that all the binary tree or the binary a binary heap should be a complete binary tree. And then when we perform deletion, it should be the it should be the node should be the node to be deleted will be removed, and then it will be replaced by the node at the deepest node with the deepest node, which is the last inserted node. So following the level order in complete binary tree or inserting node to complete binary tree, and then after that you perform percolation down. So before you perform percolation down and deletion, you will need to compare the children of that node, if which one is the greater or which one is actually the has the highest value. After identifying the highest value, you will then compare it to your parent. So if they are not in order, either in min heap or max heap, then you will need to swap them and then perform percolation until everything else is in order. Now, how about we are going to build a heap given a series of or given a pre or a series of numbers already. Like for an instance, there are given nodes in that particular order, and then you are tasked to create or to build a heap out of it. So to do that, you will just have to fill in the array in no particular order. I mean, in that particular order rather. So, or you can actually use binary tree in level order to make it complete binary tree, which is the first property of a binary heap, and then perform percolation. Okay, when we perform percolation, for this time we will need to follow the same way we did in deletion, which is we first compare it with the uh, first compare the children, which one is the highest or the lowest, and then compare it to its parent. So to, to actually uh, build a heap, here's what you will need, what we are going to do. So let's say we are going to perform a okay. So let's say for an instance, we are going to build a heap, a series of numbers like 12. These are the series of number 34, 56, and then let's say we have 10, 50, say we have 20, then say we have the okay. So let's say this is the series of numbers, the given numbers or the given nodes, and then we are going to build, we are tasked to build a heap out of it. So all we just need to do is build a binary tree. Okay, build a binary tree first for this one, or store this to your array. And if you are going to program this one, so you'll have to, okay, construct a binary tree first. So let's say we have 12, following the level order again. 12, 34, 56, up here 10, 50, 12, 34, 56, 10, 50, 20, and then 25. Okay, let's say let's add more. Say we have here 35 up here. And your add in the at the child of left child of 10 is 35. So let's say this is our uh, binary tree. Okay. So, and then we are going to build a heap out of one. So to do that is you will need to, the first step is you will need to compare the node by level order, starting with the deepest, the deepest node. So the last inserted element, which is let's say 35. So since it doesn't have any sibling, I mean wala siya igsuon, no? Wala siya sibling. Therefore, it is automatically compared to 10, okay, to its parent. So when you compare it to its parent, so is 35 greater than 10? Okay, that's actually 35 is greater than 10. That's actually true. Therefore, swap na to si 35 and 10. So this will have here, this will be 35 and this 10. So the now you have here 35 and 50. Okay? So compare 35 and 50. But by the way, before that, para dili ta mali di ay no. So you can actually follow this. Sometimes kasi there are instances na you will arrive different output if you will uh, you will parang unahon nimo tanan ang left subtree. So kasi dapat we have to follow the complete binary tree level order na sequence, which is, so this, since this is the deepest node, no, level order, which is after na compare na to si 35 and 35 si 35 and 10. So that's the okay na. So next level na punta. So the next level is this, actually 10, 50, 20, and 25. But in this case, since we have here since we have, this is the last or the recent, kumbaga, if we are going to insert in node, no, so kung insertion of node, ang next sa kanina level is this one. Kumbaga, dirita last nag-insert of node. So therefore, diri sa ta mag-compare. So first is compare nimo ang children. So which are 20 and 25. So which one is the kinsay highest or max value nila? This is max heap, by the way, ha. Max heap day ato. Max heap. So 20 and 25, ang greater is 25, and then i-compare nimo siya with its parent. That's actually false. So heap order siya. So nothing is going to be changed. So, or nothing is going to change. Now, right here, to sa left side, then we have here 35 and 50. So since 50 is greater than 35, therefore, kaniyang ato ang key. And then i-compare nato na siya with its parent, which is 34. So 50 and 34, that's actually true. So this mag-swap si 50 and si 34. Okay? And then compare na po nimo si since wala na may next level, no, ang kanina na siblings 50 and 56, therefore 50 and 56 will be compared, and then After that, when you compare 50 and 56, ang highest or greater sa ilaha is 56. Therefore, iswap nimo na sa iyahang parent which is 12. And then, swap nimo siya si 56 and 50. So, okay, let's check. Ako ato ang tarong na to ang binary tree ay binary heap. So, after binary tree, so this one is dapat mahimo siyang binary heap. So you have here 56, have here 12, uh, then followed by the children 20 and 25. And then in the left subtree, you have here 50, yes. And then you have 30, 34, you have here 35, and you have here 10. So let's check our heap property or our binary heap if tama ba ang iyahang order of property. So first, is it by complete binary tree? Yes. Kasi all complete already filled ang tanan niyang nodes. So next na mag-insert ang node would be there is 35. And then is it following the heap order property? Is 56 tanaw na to? Is 56 greater than the children 50 and 12? Yes. Is 50 greater than its children 35 and 34? Yes. Is 12 greater than its children 20 and 25? Yes. So it's 35 greater than its child, which is 10? Yes. So that's it. Our binary heap is a heap, okay? Or our tree is a heap. Okay, let's try another example. Okay, let's say kanang daghanon na to siya. Let's say for instance, we have 12, 18, 100, 75, 10, 50, 60, 7, 5, 25, 30, and then say 45, 40, 40, 40. So we'll need to create, okay, first is construct a tree. So first step is, again, construct a BT, or is if i-program nimo siya, store it to array. Okay, and then after that, yeah, that's the first step. So going to perform binary tree, or we're going to create binary tree out of this one, 1800, following the level order para complete binary tree siya. And then you have your 75, then 10, or 50, then 10, 50, 60, 7, 5, or 25, 30, 45, here, sorry, here, 40. Wala na ini siya. Anyway, keep ni siya, wala na siya. So that's it. Let's check na to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. Okay? So, i-change na po ang color. We are going to change the color of our pen, ibog. So, this time, we are going to perform percolation. Okay? So, to perform percolation, we need to start with a subtree where ano na to into level order asa ang last inserted node. Last inserted node na to is kanina part dire. So since kanina part dire ang last inserted node and naa siya ang 45 and 40 are siblings, you will need to compare them. So compare nimo si 45 and 50, 45 and 40. That's actually 45 is actually the highest node. But when you compare it to to its parent, so it's actually less than to its parent. Therefore, uh, we don't perform percolation. Okay. Next is we move to the left subtree. So you have here the this node or this subtree. So we have here is 25, which among 25 and 30 as a children, asa dira ang highest. So we have 30. Therefore, 30 is the key. So we are going to compare 30 to its parent. So is 30 greater than 10? That's actually true. Therefore, iswap na to the 30 here, 10. Okay. Next is um, you go here, okay, because this is the next level. So you will need to compare 7 and 5. But again, since in order siya or in heap order na, you don't have to do that. But since the algorithm is should be following whatever we are writing, so because again it's all I mean that's the algorithm, so you'll need to follow that. So among these children now 7 is greater, so i-compare nimo sa parent which is false, therefore no changes. And then after that balik ka diri sa right subtree. So you have your 50 and 60, which one is greater? So 60, kung compare nimo sa parent, so it's in order. So therefore, dili nimo siya i-pair. Ay, dili nimo siya i-swap. How about here? So which one is greater among the children? So set 75. So therefore, 75 will be the key. So you will compare it to 18. When you compare it to 18, that is actually true. Therefore, you swap 75 and 18. So now, next is the sub 3. Okay, kanina na level. So first level or level 1, we have here 80, 75 and 100 rather. So which one is greater? So we have 100. Therefore, what we will do, so 100 is the key and then compare it to the parent which is 12. So it's actually true. Therefore, swap 100 and 12. So when you swap 112 and then 100 now is the root node. So therefore, our node or our final binary heap is our binary heap now. So by the way, you have here a lot of natawag na to of percolation. Okay? So our binary heap is 100. Okay? Mhm. Followed by the left node of 75. Then we have here 12, I guess. Then we have here 50, 60, and in your 50, nakakate 45, and then 40. Your left subtree of 75, you have here 18, okay, and then you have 30, and then 25, and then you have here 10, and in your sa 18, you have 7, and binary. Anyway, so let's check the order of heap property order if tama ba. So I mean, check sa ato if binary complete binary tree ba siya? Yes. Okay. Is it binary heap? Okay, tanaw to if nag-follow siya sa heap property order. So we have here 100 is greater to its parent. At 100 is greater to its children. 75 is greater to children. 12. So you still have here. Okay, since napaday tay wala na order, therefore, so I just forgot this one, no? So since naatay wala na order, may natang gibalikan ato atong gi-check. We have here 12, 50 and 60. So you have 50 and 60, which one is highest? So we have 60. Therefore, what you will do is yeah, so what we'll do is swap 60 and 12. So you have your 60, 12, and then ang 60 doesn't have any children. So start na siya na. So ang heap would be this 60 daini. This is okay. So are they in order? 60 is greater than its children? Yes. 50 greater than the children? Yes. 75 greater than children? Yes. 18 greater than children? Yes. 30 is greater than children? Yes. So it's a binary heap. So that is how you construct a binary heap. Okay, so thank you guys for watching this video and have a great day. Bye bye.